Okay. So usually I start with by asking what is cloud computing, and as you rightly said, uh, cloud. So when you say cloud, right? Cloud is all about having your infrastructure available somewhere else instead of you having your own machines and all the infrastructure at your place. Suppose if you want to build an application, right, like using Node.js or whatever the technologies that you want to use, right? So you may need a lot of infrastructure, right? And if you are building a website or something, then definitely maybe you have to take a computer, buy a computer, and then install all the applications, install the operating system, and make sure that your computer is access online to all the people who are trying to access your website, correct?
Yeah, Ravi.
Yeah. So, but again, the problem with those kind of things is that whenever you set up your own infrastructure, you need to put an investment, right? And whenever you put an investment, you need to also make sure that your computers are always online, and they are never out of order. Because when people are actually using it from outside, they don't want any computers to be down while they are using their website. So, and also, usually what happens is when more and more people are accessing your website, the load on your server gradually increases. And every computer that you are using has a limited amount of CPU, RAM, and many other things which are pretty much limited. Like if you buy a computer, right, usually you have certain amount of RAM, certain amount of CPU, certain amount of hard disk, right? So these are the three standard things that we look for whenever we go for any computer. And similarly, you did the same thing when you set up your own computer for the outside world. Now, let us say your website has become a little bit popular and many people are accessing your computer continuously, then the load on your server also increases. So you need to gradually keep on increasing the resources on your computer. So after a certain amount of time, what will happen is your computer will become slow, right? Because when many requests are coming onto your system, right, then definitely the computer will become slower and slower. So let us say this is your, maybe you have taken some rent somewhere, and then you set up your own office, maybe somewhere you set up a computer, and you started interacting by writing some web pages, coding, and all these things. You might develop an application, or maybe because you are the owner of this website, you may not have time to develop web pages. You may have to hire people who can actually develop, maybe these are developers who are going to develop your web pages. So you need to basically take care of them, give salaries for these people, that anyway you have to do it. And also to buy this computer, you need to put some investment, right? Um, so now people from outside will start accessing your website. Initially, maybe there are not a lot of people who are actually accessing it, so it is fine. Your application is working well. But as and when you do market your application and more people are accessing your application, right? It's quite possible that the application can actually become slower and slower over a period of time. May not be immediately. Over a period of time, it can get slower. So in order to give a good experience to the users, right? Uh, what are the things that you can do? Do you have any suggestions? So the application is getting slower. So what else you can do?
Yeah, so here actually the number of servers should be increased, and also we need to
Increase.
take care of the load balancing factors actually.
Yeah. So here you need to add more servers, and just adding the servers won't be helpful because the clients doesn't care which server they are going to. They don't even know. So we need to actually put a load balancer which will have a unique IP address or a unique domain name server, which we are going to give it to the clients, like Amazon.in, right? There will be standard name, and behind the scenes, it should actually send the traffic to all these servers. So now, what happens is if you are the one who is maintaining all this infrastructure, right, you need to make these investments of buying these servers. So these servers also you have to buy, and you need to have network engineers to connect them to the network, adding, writing code for load balancers, which are all very complicated in the real world. You need to, they are all softwares, right? So those are some complicated things that you need to do. And let us say you have done that, you have a lot of money, you have put all the investment and everything. But the problem is, what happens if this whole building on which, or maybe the room in which you set up all your computers and the servers, right? Suddenly, God forbidden, there is a fire accident or a power fluctuation, and suddenly everything is burnt. That is also you need to plan for, right? If something happens like that, then your servers are gone and your data is gone, and there is no backup unless and until you have already taken a backup. It's not very useful, right? So usually, the computers where you actually set up all your infrastructure. So this is basically your infrastructure. What is infrastructure? The place where you set up your computers, where you have the electricity, and whenever you have computers, right, you definitely have all these air cooling systems like ACs, so to keep the environment cooler. So all these forms under your infrastructure. So this kind of a setup, right, we usually call it as a data center. So a data center is basically a geographic location where your infrastructure is actually set up, right? And whenever someone sets up their own data centers or infrastructure, right, we usually call this as an on-premise setup. On-premise means I am responsible everything for my own infrastructure. If anything happens to it, no one else is responsible. I am the one who is responsible. So if something is completely burnt out, I have to basically replenish them with new computers and all these things. And usually when your business keeps on growing, right, I need to add on I need to actually add on more and more computers, and then I need to keep on replenishing them with whatever we actually need, which is actually not a very good thing. And that's not the only thing. One problem we saw that if everything is gone, then that's a problem. But there are other problems also. We usually call it as elasticity. So what does elasticity mean? Suppose today I actually set up 3 computers, right? And I am expecting a few requests. By looking at the pattern, right? Maybe I got 100 requests from my clients. So I set up 3 computers. And suddenly tomorrow I have like 1,000 requests coming in, right? So 1,000 requests means even these 3 computers might not be sufficient. So what I have to do is I need to do something called as scaling. So to support these 1,000 requests, right, I may have to immediately add a few more computers just to make sure that it will handle those extra requests also. So that will definitely increase the expenditure, and you have to do it very quickly, right? If you don't do it quickly, you might lose the business. Right, so that is one problem usually companies face when more demand comes in from the clients. Right, you do not have enough infrastructure to scale so that the requests are handled satisfactorily. right? So that is one issue. And of course, yeah, you what do you do is you actually launch a few more machines or buy a few more machines, which might actually take more time. And if you keep on buying more and more machines, right, you need to get at them at a cheaper price. So you go to IBM or with various other vendors to get all your infrastructure, to get them into contracts, licenses. Lots of issues will be there, right? And that is one issue. Now, let us say you increase your computers, let us say to 50 computers, because you saw that there is a continuous increase in the demand. Okay, you satisfied all of them and everything was fine. But what happens when there is no demand or when there is a lesser demand? So you already bought this infrastructure and now you are not getting so many requests and you don't really need these extra computers. You cannot get rid of them because you already bought them, right? So that is what is happening with most of the companies very initially. So I should be able to increase the number of computers and decrease the number of computers at my will, right? Which is what we call it as elasticity. Increasing of resources or decreasing of the resources at any point of time is what we call it as elasticity. And this kind of thing, flexibility, is not there if you are setting up your own on-premise infrastructure. That is actually a very big problem. And of course, you may have your own security and all these things, but what people usually do is, in order that they don't suffer data losses and all these things, they redundantly store all their information at some other place, which also increases the cost. And usually they duplicate their data centers and put their create another data center, maybe it's at a different place, so that they act as backup to each other. So that will also again increase. So they will set up another data center which is just acting like a backup, and there is a disaster recovery system available, and you have to basically bear the expenses and all these things. So setting up an infrastructure, your own infrastructure in an on-premise environment, is always going to be costly, and nobody other than you is responsible for that whole of the infrastructure, right? So that is the main problem that many companies have faced in the past. And it's not about just one or two computers, it's like thousands of computers that they have to maintain. Like if you are doing an Amazon.in website or any of these recent online websites, or any company who is dealing with lots of business, right? Definitely you need to have lots and lots of resources made available immediately. And also basically it should be something like an on-demand thing, right? You do not want to buy a lot of infrastructure and then you just wait for somebody to use it. So that is not the business model these days. So whenever I require it, I need the infrastructure, and whenever I don't need it, I really don't need the infrastructure, right? So that should be the case. If that is the case, right, then it will be very much advantageous, because you are not using up all the resources, and you will be using the resources only when you require. Okay, any questions?
Yeah, Ravi, everything is clear.
Okay, so but now that we know the problems of the infrastructure that we maintain ourselves, right? So a big companies like one of the very big companies like Amazon, right? What they said is that, okay, Amazon is a very big company. Initially used to be an infrastructure company, means they have a lot of infrastructure which they have already set up. So maybe they selected some place, maybe in US or somewhere. They actually have lot of these servers which are already there, and they said that if anybody needs infrastructure, right? Suppose if there is a person who wants to build a website just like before, so now I don't really want to buy all the infrastructure and all these things. So what Amazon says is that I already have set up and networked all the infrastructure somewhere at a distant place, at my own place. Maybe this is somewhere in the US, and what they tell this person is that you just have to make a request to us that you need this infrastructure. So I am going to make you available all this infrastructure over the internet. So the advantage for this particular person is they can actually do a rent on the resources. They don't have to buy anything here. They cannot buy. They can request and then rent for the resources. Resources means it could be servers, it could be storage servers, it could be network. It is absolutely anything. So you can rent whatever the infrastructure that Amazon or any, even Azure, Google, any company, right? They say that we have the infrastructure. You just have to make a request to us, and we are going to give you all that infrastructure that you need. So this way, what will happen is I don't have to make any kind of investments on infrastructure, and even if I want to increase the resources, decrease the resources, it is the complete responsibility of the provider that who is giving you all these things. So what Amazon says is that how do you basically interact with me, right? So they actually come in between, because this is their physical infrastructure. This is their own on-premise infrastructure which they have already set up, right? And they are going to build a website so that we as customers or anybody who wants to build applications, right, for interacting with them, they are going to build a nice website in between their infrastructure and the actual customer, right? So this is going to be something like AWS dot Amazon dot com, something like that, some website. So what they say is you actually come to me and register on this website. So once you register on my website, I am going to give you access, basically a remote access to all my infrastructure, right? So if you just want a server, right, so here you are going to basically say that I need one server, and using this request, what Amazon will do is Amazon will go to one machine and then create a server for you on the go, and then they are going to give a remote access. So you don't have the physical machine, but you will have the remote access so that you can connect to it as if it is your machine and then start using it, right? And if you need more resources, right, they will automatically instantiate new servers for you and create them in within no time, and then they start assigning them to you, right? Suppose previously we have the example, right? If more and more requests are coming to me, then they have a lot of features. So usually they use a feature called virtualization. So virtualization, I will actually talk about this in detail later. So do you know what is virtualization?
Yeah, virtualization means actually it is something like pseudo kind of activities where the physical resources are not directly available,
Yeah.
but we can use them on demand, online actually.
Yeah, right. Yes. So yeah, exactly the same thing, but I will talk about this in detail. So virtualization is basically instead of using a physical machine, right? You take resources, rent on resources from the base machine, and then you can actually use. Basically, they are software machines rather than physical hardware. They are software machines, or many people call them as virtual machines, right? And then you can actually use them as if they are physical machines, even though they are not physical machines. So Amazon actually works on these virtual machines, and then they are created usually in 10 to 15 seconds. As compared to a physical machine which boots up maybe for 1 minute or 1.5 minutes, right? They are actually booted up very, very fast. And if you don't want, you can actually shut them down, or even what do you call, terminate them, and you don't even need to use them. So, so basically, the idea here is it is the responsibility of this provider to make sure that you have the resources at any point of time, right? So this layer is what we call it as the cloud, because it is coming in between the actual resources that Amazon has and the ultimate customer. right? So this layer, right, is typically what I say that it has cloud, because we don't see what is beyond the whenever we have a cloud layer, right? We don't see what is there beyond the cloud, but we will get all the resources that are made available. So when you are saying I am using cloud means, right, you are actually using resources which you will never be able to see in your lifetime, physical machines, but you can interact with them through this particular layer, and then start accessing as if you actually own a set of resources, and as you rightly said, you just pay only for the resources that you are using basically, and get the resources only on demand, means only when you require you use them, and when you don't require you don't pay anything. Suppose if your number of customers are reducing maybe in the morning, right, you can actually tell Amazon that please don't use this server, just terminate it. I don't want to pay for it. And if the load is increasing, you can ask them to increase the servers, and then add more capacity, so that your overall user experience is not affected. Right? So that's how this is basically a cloud technology. It is nothing specific to any cloud provider like Azure or Google Cloud or even Amazon or AWS. This technology is basically cloud technology. So whether you are working with any of these major cloud providers, right, they have very similar setup. Maybe the way they provide the infrastructure and all these things may be different in a different type, but ultimately the technology is the same thing. They have their infrastructure at one place, they have a website, and the users are going to register and then pay for all the resources that you are using, and they are billed on a monthly basis, so that they don't have to really do any kind of huge investments. You will be billed on a monthly basis. So if it is a virtual machine, they are going to charge you on a per hour basis. If you are actually using a storage server, they are going to charge you per month on a per GB basis, how much of our data that you stored, they're going to charge you based on that. So everything is basically billed as per the requirement, and then over a longer period of time, right, you reduce the amount of billing that you see on your accounts. So many companies, right, they actually try to do this kind of infrastructure management to reduce the costs. And of course, many companies have their own on-premise infrastructure, and they can either replace it with, or if they cannot replace, they can extend some of their services to cloud, and they can still continue with the on-premise infrastructure also, right? So basically, if you want to put this into some kind of textbook definition, right? So basically we say the practice of using network of remote servers hosted on the internet to store, manage and process data rather than a local server or a personal computer. So here you just need to have one computer with a good internet connectivity, then you can actually connect to this cloud environment through the website, and then own a lot of infrastructure remotely and access your resources remotely. No need for a to buy computers or work on within your own computers. So cloud computing is an on-demand delivery of compute power. So compute power means usually the RAM you want, the CPU you want, all these things, right? You can actually demand the cloud provider that I want more RAM, more CPU, more machines. Anytime you want, it's an on-demand delivery, right? Whether it is a database storage, whether you want to have applications, any IT resource, right? You can get it through this cloud services platform. So we know, right, what is a cloud service platform. So infrastructure at some place, the website, and then the customer. There are three layers, right? But somebody has to provide that infrastructure. They have to build a website and all these things, right? So that's where Amazon actually comes into picture, right? So Amazon actually built a lot of infrastructure, and they exposed all their infrastructure to the clients using the intermediate layer, which is called, they call it as the cloud. And Amazon actually calls this as AWS, Amazon Web Services. And why do they call it as web services? Because what Amazon has done here is because they have to service the clients, right? So different clients may have different requirements. So somebody wants to build an application. Somebody wants to build a machine learning application, which is very, very complicated. And somebody wants to run some big data related applications. And somebody wants to build a simple website. And somebody wants to maybe use the cloud as a simple storage, right? So different people have different requirements and they cannot just satisfy all the different disparate customers with only one service, right? So that's why they have actually divided their offerings into a number of what they call as services. So they call it as services. So a service is something which Amazon offers, and they are going to, of course, charge for it based on what kind of service that they are providing. So an example of a service is basically you need a simple server, right? Because you have a lot of web pages and you want to host them, and so that you can actually give it to all your clients, right? So so in order to host an application, right, what do you need? You need a server. And when you talk about a server, right, you have to choose what is the hard disk, what is the RAM, and what is the CPU, right? So in order to provide all these things and what type of server you want, what operating system you want, whether you want a database server installed on it or not. So in order to choose all these things, right, definitely you need a machine. So in order to select all these things and then create a server and maintain all those things, right, Amazon has actually created a service called EC2, right? Elastic Cloud Compute. So this service will completely take care of your virtual machines. Just now I told you, right? All the virtual machine related things. So it is dedicated only for doing that particular service, right? But another client may have another requirement. They don't want any of these servers. They actually want to have a lot of data which they want to very safely store somewhere, right? So Amazon has another service called S3. S3 means simple storage service, where you just store data. You can store unlimited amount of data in S3, right? Just it is just like Google Drive, where you can keep on storing as much data as you want. So like this, Amazon Web Services is divided into hundreds and hundreds of services which Amazon will keep on building, and we as application architects or cloud architects or cloud engineers, whatever, we need to see what applications we are trying to build and what services we actually require from Amazon, and then use them and complete our application. So that's why as a cloud engineer or a cloud solutions architect, right, what you need to do is you need to understand as many services as possible. And it is practically impossible to learn all the services, because Amazon, every day you see there is a new service that is being added, and it's very difficult for us, even for me, even though I'm doing this from the last 7 years, I'm still not well versed with many of the services, because they just keep adding services because of the features that they are required by the clients, or maybe because of the competition from other cloud providers, right? So, but there are some basic services which anybody has to know, like EC2. So building a server is the most common thing, and storage is also the most common thing. Building database applications is a very common thing. Networking is a common thing. So like this, there are many services which Amazon provide. No matter what kind of role you are playing, right, you definitely need to know all these services. So initially what we'll be doing is how we are going to understand how Amazon is providing these services, and take each and every service and start looking at that service and see what does it do. Then you can actually relate it to what you have been doing in your own on-premise computers till now, and what is the main difference between the cloud computing technology and basically an on-premise technology. Okay. So, cloud computing is something which is everywhere, even though without our knowledge we have been using it, like sending an email. If you look at Google email, right, like Gmail, it's a cloud service. Somebody has already created an application online. You don't download or anything. You keep using it in the web browser, right? So basically, it's a cloud service or edit documents. Any of these things, right? We have been using cloud without even our knowledge, whether you are sharing photos to your mobile users or you are supporting critical operations of your business, right? So these days most of them are actually deployed on a low cost cloud computing. Why I'm calling it as a low cost resources? See here, when there is a cloud computing platform, right, it is not that only you or I using it. There are many people who are actually using it. And what Amazon is doing is it is actually sharing all the resources across multiple people. And that's when you realize the nature of the whole cloud environment, right? Whenever you share something with others, right, it tends to become cheaper, right? Like if you go to Uber, right? So Uber buying your own car versus taking Uber, right? So buying your own car means you have to maintain it, you have to put petrol, and you have to take care of your car. That's a little bit problematic, right? If you think so. But otherwise, if you don't want that headache, you can always hire Uber and then just pay only for the ride that you have taken. So basically, to sum up the whole thing, right? This is one of the best examples that I can give. And also, if you take Uber pool, right? Like if multiple people share that Uber, the cost will even come down, right? So that's why Amazon also has set up the same thing. If many people are coming and using Amazon services, right, then it becomes even more cheaper for people who are using it. It's a win-win situation for both Amazon because they are getting more customers, and it is also cheaper for the consumers because we are getting at them at a very low cost. And with cloud computing, you don't need to make a large upfront investment in hardware and spend a lot of time heavy lifting, the managing that hardware. So that is one of the biggest things when you maintain the hardware, right? So you need to have engineers, operations engineers, infrastructure people maintaining them. Something happens, wrong happens, then you have to be the responsible person. Now with cloud computing, right, you don't, you actually outsourced all these things to Amazon or a cloud computing provider so that you don't worry about all these things. You only worry about what you want and pay only for what you actually have consumed. And you can provision exactly the right type and size of computing resources you need to power your newest bright idea, right? So if you want a 10 GB RAM, you can quickly get the 10 GB RAM. If you want to have 20 GB RAM, within no time you can actually acquire those resources. When you want to reduce it, you can reduce it. But when you with your on-premise infrastructure, right, you cannot do that. Once you buy it, that's it. You bought it and you already spent the amount on it. So you cannot actually increase, decrease your resources at will, right? But with this, you can actually exactly take the right number of resources and increase, decrease resources whenever you want. You can basically be more elastic in nature. And the more important thing is you can access as many resources as you need, and you get the resources instantly and only pay for what you use. This is the one of the best use cases of the cloud. So you say that I want this, and that resource will be available within no time, and you can start building your application immediately. So you don't have to wait for anything else.
Yeah,
So
Ravi, I
cloud
have a
computing,
question.
yeah,
Yeah, you said that Gmail is a cloud service, right?
yes, it's a SaaS
So
application.
how to consider that as a cloud service?
How do consider cloud search means? See, basically they have actually built that application. See, in order to build Gmail, right, they need actually some software, right? So they've actually taken some servers behind the scenes which we don't care.
Okay,
As a user, I don't care.
okay.
So they have actually built it behind somewhere, and I just go there and access Gmail, and it's actually a free service. Of course, if it is an chargeable service, they will just charge you on how much of what is the capacity of the a number of emails or storage, how much storage they give. But we just access it online, and then we are done with it. And if there is any charges, we pay by particular type.
So in that way, definitely the Instagram, Facebook, almost all the
Most of
social
them.
applications are running through cloud, right?
Proud, yeah. These days,
Yeah.
you don't even realize, even if you go to maybe Ghana.com, right? So
Yeah.
the actual people who are from Ghana.com, right? They don't even create any infrastructure.
Mm.
They are just going to cloud, take a server, put all of them there, take a server, take a maybe something like S3, where they store all their music-related MP3 files, and then they just build a simple application on one of the servers, and then provide links to them.
Okay, okay, got it, Ravi.
Right? So that's why you don't even know that it's a cloud service.
Yes, yes, got it.
If you take a Gmail, sorry, G Drive, that is also a
Mm.
cloud,
Yes, yes, got it.
where you keep in uploading something, and then they what they do behind the scenes we don't even care, and we just,
Yes.
if we want more storage, we'll just buy it.
Yeah, just giving this G drive interfaces as a layer, but behind the scenes
Layer,
they are
yes, exactly.
storing
Yeah,
somewhere in
they
the
build
data.
the layer because for us they have to interact with that, right? So they
Yeah.
just give a layer by, and also that is also an application running on some server.
Okay, got it.
And we as users, right, we don't pay for the server, we don't even bother about the server, we only pay for the service.
Yes.
Okay, again, I will further tell you, you think, I think you already know, that is actually a SaaS server, SaaS service,
Yes, yes. Software as service.
software as a service. They build the software already, and
Yes.
you don't care. We just pay for the service. That's it. Like Salesforce, right?
Yeah.
Salesforce is also a SaaS service. You don't care what is the platform that they use, what is the infrastructure that they are using. You only use that service, and whatever the charges for that service, you pay for that.
Yeah. It's clear, Ravi. Thank you.
Yeah. Okay, so a cloud services platform such as Amazon Web Services owns and maintains the network connected hardware required for these application services, while you provision and use what you need via web application. So they basically give us a web application which we need to register, which we are going to do it after this, and then everything is actually done through that particular website. And again, if you want to see these things, so trade capital expenses versus variable expense. So if you are maintaining an on-premise infrastructure, right, you have a capital expense, means you have to get a lot of capital expenditure, buying servers and all these things. But now you actually trade it with variable expense, because you are paying only for whatever resource that you are consuming, right? So maybe at the end of the month, you just pay for it, and benefit from massive economies of scale, because a lot of people are actually using these resources, right? Then the scalability is also very huge, and because of the scalability, right, every person will get the resources at a very, very cheaper rate. So that's why you benefit from economy of scale. That's what they say. And you don't need to guess the capacity. So if you are building an application, right, how many servers do I want? So if I buy 30 servers, let us say, what happens if the 30 is more than what I required? Right? I need actually only 10 servers, but just in case my resources increase, my requests increase, I buy 30 servers. It is a waste of resources. Or sometimes it is other way also. I actually needed 60 servers, but I bought only 30 servers. Again, that is also a problem. So you need to look at your application, how many users, and exactly guess it when you are using on-premise. But with cloud, right, you can start with a certain amount, and then because you can actually get the servers on demand, right, and within no time you can scale up or scale out or scale in whenever you want it. So you don't have to guess the capacity of what the infrastructure that you are going to have. And this will give you a lot of speed, because all the infrastructure is maintained by Amazon, and it also give you a lot of flexibility. And you don't have to create your own data centers, maintain them. Nothing is required from your end. You just basically register with a website and start using them. And the most important thing is you just go global in minutes. If I have a website, take a server from Amazon, deploy it onto the server, and you are basically on the internet. You just have to share your details to your clients, and then they will start using your application. So basically, we call it as the three different types. I think you already know, but I will just finish them off quickly. So we have this infrastructure. Basically, we call this as service models, infrastructure as a service, right? Amazon is going to, or the cloud computing platform, right? They're going to give you all the infrastructure. So infrastructure means all the virtual machines, storage, hard disk, servers, network, load balancers, everything is built, and you are taking them as a service. So you have to pay for that particular service. So basically, this is called as the base layer. And then just having the infrastructure is not sufficient, right? So we need to have, suppose if you are building a Java application, you need to have a Java runtime. If you are building a database, you need to have a database layer, web servers, application servers. All these things are required. And most of them require licenses and all these things, and you don't really have to worry about them, because Amazon or any cloud computing platform itself will provide you all these services, which they call it as the platform as a service. So basically, they actually go hand in hand. Anybody who is building an application, right, definitely they require an infrastructure as a service. They also require a platform as a service with which they start building the applications. And the third one is the software as a service. So some people, as I just now told you, the G Drive is a software, is an application. So when we use the Gmail, right, or G Drive, we don't care what platform it is or what infrastructure they are using. We care only for that software, like Salesforce, any email or application, social networking sites. They're already built, and if at all we have to pay, we just pay for whatever the service that they are providing. That's it. We don't care about any of the infrastructure or platform as a service. But these are the three basic models on which the cloud service platform is going to work for us. So here, if you actually look at this, right, in the on-premise thing, the green things are something that you manage. So network, you in the sense, when you set up your own company without any cloud, right, you take care of networking, you take care of the storage, servers, virtualization, operating systems, middleware, runtime like Java, databases and all these things. The data that you are hosting, applications that you are hosting, everything is your own responsibility. But if you start moving towards any cloud infrastructure, right? And if you say that I am taking only infrastructure as a service, out of these things, the networking, storage, servers, virtualization, everything is the responsibility of the cloud. Right? Like if you take AWS, it is the responsibility of the AWS. If you take the platform also as a service, then the operating system, middleware, runtime, all these things are also the responsibility of the cloud environment, right? And if you take software as a service, even your data, the applications that you build, it is the complete responsibility of the cloud provider. Like if you upload a document onto the G Drive, right? You don't have to worry about any of those things. Google will worry about it, right? So whatever the application that they have exposed it to us, like using that G Drive site, right? We don't care. The data that we uploaded to there, we don't care. They will actually, the security, encryptions, all these things, they worry about it. But if you take only the infrastructure and platform, then it is your duty, the client's duty, to make sure that your data is secure and your applications are secure. Those things you have to take care of it. So like this, depending upon what level of things you want, and there are different levels of security for different layers, right? So here there is a maximum security which the cloud will actually take responsibility for, but as it goes in this direction, there will be more responsibility on the customer. So usually they say that it's a shared responsibility model. Some responsibility definitely will be there on the customer, and some responsibility Amazon or any cloud computing platform will take it. And here we have these different types of cloud deployments. So the first one is actually called as the private cloud, which is also what the on-premise we were talking about, right? Many companies, right, before maybe 20, 30 years back, they're all on-premise. Everybody used to build their own infrastructure, their own data centers, and make sure that they're all proper, they have right engineers to manage them. But that has becoming an increasingly difficult task from the operations perspective and also from the expense perspective, right? Because you have to buy servers and maintain all those things. So many of these people, and here in a private cloud, right, the servers are accessed only by people who are belonging to this company only. So if I'm working for a company, only the people who are working in that company will have access to those computers, right? Nobody from outside. So if somebody is there from outside, they cannot enter into their infrastructure, or they cannot access their server. You have to be an employee of that company to access any of those servers. So the security is very tight with firewalls and all these things. Make sure that hackers or anybody, it is very difficult to enter into the private cloud. So the security is very, very huge on all these things, right? But when you come to a public cloud, like the cloud computing platforms like Amazon, Azure, or Google Cloud Platform, right? They are all public clouds, which means that anybody who is there outside, right, they can enter into their system and start accessing their servers. Of course, there is some authentication, authorization, and all these things, using which they can start accessing the servers. So private cloud, nobody can from outside can enter, but in public cloud, it is meant for the public so that they can actually access the resources that are available somewhere else. And there are some companies where they say that I need my on-premise infrastructure, I cannot get rid of it. I still have to use it for some things, but for some services I'm going to use the public cloud. That is also possible. When you have such a setup, right, we usually call it as the hybrid cloud, right? Where you have a bit of private cloud, you have a bit of public cloud, and there is a strong connection between them. And Amazon definitely give you a lot of services which makes your on-premise interact with the public cloud. Suppose if there is an application here which is running and it is actually generating a lot of data, right? And you want to take this data as a backup and store it in the cloud, because there are a lot of advantage of storing the data in the cloud. So whenever the application writes data to your on-premise server, automatically you want to push this data into your cloud, right? So there are a lot of services which Amazon gives you, which you install it on your private cloud, which will take these things and put it in the cloud. So that kind of a setup, right? Usually we call it as a hybrid cloud. So for public clouds, right, you as a customer don't need to do any investment, complexity is reduced, and flexible pricing options, because you are not buying anything, right? If you are using resources more, you pay more, or otherwise pay less. Private cloud, very highly regulated, strong security, and it's the most expensive solution because you have to put a lot of investment. And of course, hybrid cloud is a combination of both. If you want to reduce some costs, you can put them in the public cloud, and if you want to have security for certain things, then you can keep them in the private cloud. So what is AWS? So till now we have been talking about the cloud computing platform, but what exactly is Amazon Web Services? It's basically a comprehensive, evolving, on-demand cloud computing platform provided by Amazon. So this is Amazon's way of providing this cloud services. So it gives you infrastructure as a service, platform as a service, and also the packaged software as a service. And anybody can use it. Can be leveraged by companies, governments, subscription. But of course, you have to take a subscription, and then we can start using it. And also, when people are Amazon basically wants people to as many people want to use it. So for people who want to learn, they give you a free tier so that we can explore the services, start using them at a for many services at free, and then we can start using it. We'll create it. Do you have an account already?
Yeah. Yesterday, just I have created an account, Ravi,
Oh,
but
okay,
I
good.
didn't verify those things. because
Yeah,
it's
we'll
available
do that.
and everything is
Yeah, we'll
available.
do that. Yeah, we'll do that now. So AWS cloud versus on-premise, again, the same points. Maybe again, I will just repeat. So OpEx versus CapEx, operational expenses versus capital expenses, we talked about it. Time to deploy, because everything is a virtual resource, right? Deploying the things will be very, very easy. We will try to see those things a little bit later. And creating test and dev environments are made easier. So with the DevOps related kind of applications, right, we can build our environments very easily. So usually we have infrastructure as code type of services where if you want to create a development environment, we can write some code where it will create all the infrastructure on the fly, right? And then if you want to build a similar infrastructure on a test environment which has to be exactly the same as dev, we can run that code and it will automatically create the same infrastructure, right? So those kind of automations we can actually do very, very quickly and effectively in cloud environments. And we can make changes. Elasticity is one of the very important things, increase and reducing the resources whenever we want. And as I said, automation is always a very big option. But the only disadvantage that usually people may think about it is the lack of visibility of where my data is. Because in an on-premise, right, you are storing everything on your computer so that you are very confident about where your data is and are anybody uh, fiddling with your data or not. It is very easy to put checks on it. But here, whenever we upload something onto Google Drive or something, right, it is Google's responsibility to store the data and give it back whenever we ask for it, right? So if you are storing any confidential data or very, very sensitive data, right, is it okay to store on some other server, right? But what I feel is cloud servers are very, very secure. It doesn't mean that if you are storing somewhere else, Amazon will actually see your data and then start giving it to others. If that were the case, we would not be talking this day. Because any cloud computing platform, right, take their customers' data as the most priority thing and make sure that only the clients have access to it. They give you lots and lots of tools to secure your data, and Amazon will never ever have access to your data. And it is actually the safest place to even better than on-premise, right? Cloud is the safest place because you don't have the fear of losing the data, because Amazon will actually copy your data at multiple places, and even if one server is down, you will actually get back the data from some other server. So those kind of many advantages that you are going to get, which you are going to see when we store the data. So it's actually not a problem. Data is always safer, even though definitely there are a lot of people who are hackers and all these things who will always try to get your data. That problem is there with anywhere, right? But yeah, the good thing is that they are going to give us a lot of tools with which we can make our applications very, very secure.
Yeah, Ravi, does it happen anytime the hackers hacks these cloud services in
Yes, a
history?
lot of companies actually recently, I think some of the, I think in Singapore or something, they
Mm-hmm.
entered into their computers, and then actually one of my friends, they are a complete cloud company,
Mm-hmm.
and somebody actually entered, even though they have a lot of the, what do you call, uh, the services which have put them, right, they will try to find something. That is what the hacking all is all about, right? No matter how much you do it, right, they try to, it is like virus, right?
Yeah.
No matter how many antivirus you put, right, they will come up with a new thing.
Yes. Yes.
So they actually entered into their computers and changed the passwords
Mm-hmm.
and did all those things, and then they again logged into this, and then they put some DDoS. They actually had a DDoS attack. Do you have any
Yeah.
idea?
Yes. 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 Denial
Yeah,
of
so
service.
distributed denial of service. So they
Mm-hmm.
again came into that, and then uh, put more and more security on top of it. So it is not that just because using cloud everything will be safe. Actually, to be fair, right, when you are going to cloud, the vulnerabilities are actually more because it is
Okay.
public, right?
Yes, yes.
Once you make it public, right, everybody has access to your basically for hackers, not for like you and me. We don't even know because they are very secure. But hackers basically work like that. So yeah, once that something gets hacked, they have some kind of more security that is created for them.
You know,
Yeah,
apart from this DDoS kind of attacks, actually, of course, these kind of attacks actually may slow down the services and etc. But actually, the cloud stores the data in some encrypted format.
encrypted
So
format. Yes,
yeah, so even though hackers try to access the things,
exactly.
I think they may not see the data actually.
See the
Am
data,
I
but
correct?
they can fiddle with the data or delete it or do certain.
Yes,
Yeah,
yes.
even though we have authorizations and all these things, they have their own ways of doing it. But yeah, very rare cases it happens. Not day in and day out that doesn't don't happen. But
Mm-hmm.
yeah, it is not the most secured this thing. There are vulnerabilities there also. That's why Amazon gives you a lot of services where you keep monitoring these activities, right? Whether if something because sometimes what happens is that when hacking happens, you need to know that something has happened, right? If you don't know that, that is a problem. So the Amazon gives you a lot of services where they will actually find out the patterns and then they alert you, audit the things, and then make sure that it's available, which is usually not possible if you are maintaining your own application.
Yeah. Okay. Okay, Ravi.
Okay, so lots of people are using these services. It gives you a lot of flexibility. You can save time, money, and it's the fastest growing cloud computing platform, largest cloud computing platform. More and more companies are outsourcing their IT. A lot of certifications also available. If you want, you can do a cloud practitioner. You can do cloud solutions architect, cloud developer, DevOps. Lots and lots of very popular certifications are there. So yeah, Amazon actually started sometime in 2003. So they have a lot of infrastructure, and they said that okay, we have a lot of infrastructure. Why don't we sell it like a service instead of just keeping it? So they launched it, made it official in 2006, and Amazon.com was moved into their own platform in 2010, and they have reinvent conferences every now and then so that they bring in all their customers, developers together and improve the product. A lot of certifications, and also they keep increasing the revenue, which means that a lot of people are getting added to Amazon and then making sure that they have a lot of customers. And when more and more customer base increase for them, the cheaper and the cheaper the resources become for the clients also. Okay, so this is the basic introduction. Maybe on Monday, right? What we'll do is we'll actually go into the infrastructure part. Means how before we start the services, right? How does AWS look from behind the scenes? So there are like availability zones. There is a global infrastructure. What are the various types of services that are available? So we'll try to and what is virtualization? So we'll cover some basics of from now on we'll look at from the AWS perspective itself. How does AWS give their cloud platform and how it is organized, and then we will actually start exploring service by service.
Yeah. Okay, Ravi. It's clear. Could you please
Okay.
stop the recording, Ravi?
Yeah.